Question number 1. What is the SI unit for a force? To get a unit for a force, let's use F equals ma. If you want to make this 1, you have to make mass 1, acceleration 1. But SI units, mass is in kilograms, acceleration is meter per square second. So what this means is when 1 kilogram mass accelerates with 1 meter per square second, that force can be called as 1 Newton. So that's the definition for a unit for the force. If you look at this one, W equals mg, 0.1 kilogram mass, g is roughly 10. So this also seems correct, but the idea is only true for the earth. So the definition should not rely on any specific place, so we can remove answer C. Answer is A. Now here they talk about the circumference of a rectangle. Rectangle circumference is, let's say, 2a plus 2b, 2 times 30 plus 20. This comes to 100. Delta L, if you think about it, plus or minus 2 delta A plus 2 delta B. If you look at this one, it will come into 2 times 0.5 plus 2 times 0.5. It becomes 2 centimeter, right? Now they ask percentage uncertainty. Delta L over L times 100 is 2 divided by 100. 100 is the circumference of the rectangle, times 100, it comes to 2%. Answer is B. This question, be careful, there are 5, 1, 2, 3, 4, 5. So now the force is like this. F has been reversed, G has been halved. So new force is like this one. But actually I can replace that force somewhere. Hold on, let me think. Yes, somewhere here, like this. So the net force will be, let's say this is minus F, this is G over 2. So the net force will be from the starting point to the end point, this one. So the answer has to be D. Question number 4. They drop something from a height, at the same time they fire another object upwards and they meet at the same place. What does it mean? Let's say they meet here. At that time the other object has reached the same height and total height is h. Let's think this one goes down x distance and the lower one goes, so obviously h minus x distance at the same time. So for, let's call this one A, I write s equals ut plus at squared over 2 downwards, x equals 0 plus gt squared over 2. Similarly for the object fired upwards, I write x equal to ut plus at squared over 2. h minus x is the height he rises, ut minus gt squared over 2. Second equations. From first equation I write h minus gt squared over 2. What I did was I put for x, I put this gt squared over 2 into the second equation, equals ut minus gt squared over 2. This gt squared over 2 gets cancelled. So they are asking about time, t equals h over u. Answer is C. They are talking about air friction on an object. So let's first mark air frictional force. Air friction or drag force is always opposite to the motion of the object, or you can say the opposite to the velocity of the object, F drag. This drag force actually I can break into two parts. If this is theta, this is FD cosine theta, and there's another part, this is FD sine theta. But there's another force on the object, right? That is the weight of the object, that is mg. So these two together, so acceleration downwards, F over m is mg plus F drag cosine theta divided by m. This is bigger than g, so bigger than 9.81. And on the other hand, even horizontally there's a resistive force. So acceleration in a horizontal direction, let's say this way, is F d sine theta over m. That's also not zero. So the answer, horizontal component, is non-zero and greater than 9.81. Answer should be B. On this object there's a friction backwards, so F equals ma 12 minus F equals m2, acceleration is also 2, F equals friction equals 8 Newton, right? But the forces acting on this object are, one is the weight of the object and the other one is the contact force, and we know friction is mu times R or mu times mg. In this case mu times m is 2, g let's take as 10 equals 8. If you check this one carefully, mu comes into 0.4. Answer is B. This person climbs up. Every time he climbs up, he does work against gravity, right? So the gravitational potential energy 2 times mgh 0.6 times he does it n times equals total potential energy 6 times 10 to the power of 4. Now it is simple mathematics. 6 10 to the power of 4 equals, if you look at this one, this becomes 2 times 6 1.2, 10 to the power of 1 2, yeah, 2. From there you will get n equals 500. Answer is C. An object has friction force F forward and there's a friction force backward, which is again equals to mu r mu mg. So as this is moving at constant speed v, F has to be equals to mu mg. Power equals F times v or mu mg times v. Answer is D. The area under force and time graph gives the change of momentum. Here this area is, I will mark it as black, 20 times 0.5 divided by 2. The other area is 10 times, this length is 1. So altogether this comes into 15 Newton seconds. So 15 equals change of momentum. Mass is how much? 0.2 times v minus starting speed is 0. So starting momentum is 0. From there v is 150 divided by 2, 75 meters per second. Answer has to be C. There are 3 water samples. Sample 1 is at 60 and sample 3 at 0. So we have to understand, as there are more water on sample 1, the final temperature is theta has to be more than 30. It won't be at the midpoint or lower than 30, it will be more than 30. That with that understanding, we have to understand heat is given by sample 1, heat is taken by sample 2 and 3 both. So heat by sample 1 equals heat taken by sample 2 plus heat taken by sample 3. So heat given by first one 2mc 60 minus theta, second sample 2mc theta minus 30 because it started from 30. Last one mass is mc theta minus 0 because it started from 0. So from here mc can be cancelled. If you look at this equation carefully, you will get 5 theta equals 180, theta equals 36 Celsius. Answer is B. Same mass, which sample has the greatest number of molecules, right? Number of molecules is number of moles times Avogadro number, or you can say mass divided by molecular mass, Avogadro number. If you look at this one, mass is of the each sample is the same, Avogadro number is of course a constant. So if you want the greatest number of molecules, you have to have the smallest molecular mass in this particular example. Let's think quickly. This one, nitrogen is 14, 28, 28 plus 16. This one 2 plus 16. This one 12 plus 32. This one is 12 plus 4. Obviously this number is the smallest number, which is 16 compared to other samples. This molecular mass is the smallest, so this one has the highest number of molecules when the mass is the same. Boltzmann constant. Where have we seen this Boltzmann constant? E equals average kinetic energy of one molecule is given by 3/2 Boltzmann constant times temperature. So units, K units is average kinetic energy, joule, and temperature 1/Kelvin, so becomes joule per Kelvin. First answer is right. Second one, now where does it Boltzmann constant come from? PV equals nRT or 1/3 mnc squared bar. So this is where we make 2/3 half mc squared bar times n equals n over n Avogadro number RT. So what we do is this n cancels. This R over NA or ideal gas constant divided by Avogadro constant is what we call Boltzmann constant. So gas constant, Avogadro constant is Boltzmann constant. We agree. Third one, average kinetic energy of particles to temperature of the gas ratio is Boltzmann constant. No, Boltzmann constant from this above equation, average kinetic energy 2/3 times temperature. They have forgotten this part, so answer 3 is wrong. Answer is A. They ask negative acceleration, zero velocity. Okay, the equation for this type of simple harmonic motion we can write as x equals a sin omega t. So x dot or v equals a omega cos omega t. Acceleration a equals minus a omega squared sin omega t. So basically acceleration time graph will be a minus sign graph. Now they ask zero velocity. We know position maximum position is the zero velocity position, so answer is A or C. But second thing, they ask negative acceleration. In regards to this graph, positive is on the upper side of the graph, this side is the negative side, so negative acceleration is here, and answer is A. The speed is 270 and they ask how much is the frequency. Frequency is V over lambda. This is pretty simple, 270 lambda from here to here or here to here. You will find 1.5. 270 divided by 3 times 2, you get 180 meters. Hold on, we are talking about the frequency, hertz. So answer is A. First thing we have to understand, intensity of a sound wave proportional to amplitude squared. That's the first understanding. Second thing, intensity depends on distance. It means intensity is inversely proportional to distance squared. This is the second equation. Let's combine these two. Intensity proportional to amplitude squared, inversely proportional to distance squared, right? So let's put any proportional constant, a squared over d squared. Now when I look at this one, intensity. Now they say you need same intensity, but the distance has been amplitude is changed twice, 2 times amplitude, and distance, what should we do? Of course, if amplitude becomes twice, it will become 4 times, so distance also should be twice distance, so it will be 4d squared, right? So this will cancel. So idea is distance should be twice the distance. If you look at this equation carefully, you can get the idea. As these two wires are connected in series, so the current in the wires are the same. Now current is given by A, V, N, E, or by considering the diameter, pi d squared over 4 is the area of a circle, V, N, E. Now the current is the same, and this is the same material, copper, and a charge of electron is the same, current is the same. So you can come up with a new idea like pi d squared over 4 times V is constant, right? Or you can write it twice. So from there I can change it to pi. First wire has a diameter m over 4 times V1 pi 2m squared over 4 times V2. From there I can find V2 2 over V1 is actually 1 over 4. Answer is D. The combination of resistor, there are 3 resistors. First situation, they are connected 2 parallel and 1 in series. Second situation, all 3 are connected in series, right? So let's think about current. Current equals V over R. In first situation, this is R over 2. So V over 1.5 R is 3 ampere, right? Now I dash, second situation is V divided by 3R. So we can see this one is, I can kind of write half V divided by 1.5R, right? So this has to be half of previous number, 1.5 ampere. Answer is B. Question number 18. To do this question, we should know Fleming's left hand rule. Magnetic field strength, current, and the force, perpendicular directions, and you can find, if you know 2 of them, you can find the direction of the third one, right? So let's think, in this situation the current is going into south east direction, so current is this way. If you use Fleming's left hand rule, you will see the force is northeast direction, right? Similarly, if you think about a point, let's say B, the current is going in northwest direction, and so the force again will be in opposite direction to the previous situation. So by considering whole loop, we can feel that forces are acting in opposite direction, pulling the loop apart. So this will increase the area, so or you can say increase the radius of the loop. Question number 19. First thing to understand, that as this big mass is not going down, capital M is not going down, so T must be equal to mg, and T or mg should provide m r omega squared or m v squared over r. So I can write mg equals m r 2 pi over t squared. That's another way of writing the angular velocity. From there I can find m over m is 4 pi squared r g t squared. Let's put the numbers. When I put the numbers, 4 pi squared r is 0.25, g I take as roughly as 10, t squared, t is 0.5 squared. If you look at this one carefully, you will come across this is roughly 10, and 4 times 0.25 is 1. This is 0.5 squared means 1 over 4. Answer has to be, hold on, this is 1 over 4, it goes 1 over 1 over 4, it goes up, so answer is C. At point X, the gravitational field strength is 0, means the gravitational field strength from the earth is cancelled out by gravitational field strength of the moon. Okay, let's write the equation. G mass of earth, distance is d squared, g mass of moon, distance is, total distance is d minus small d squared. I can cancel capital G, so I can, if I look at this one, mass of the earth d squared, mass of the moon d minus d squared. Pretty simple. The answer is C. This is actually a question about memory. What is a unified atomic mass? It is the mass of a 1/12 of a mass of a carbon atom. Now sometimes the students think it is the mass of a average or mean mass of a proton and neutron. No, carbon 12 atom has 6 protons, right, 6 neutrons, right, but it includes 6 electrons, right? So when you take this mass and divide by 12, it is not mean mass of a proton and neutron. So that idea is wrong. You have to just use your memory. Remember, it's the mass of a carbon 12 atom. This is about alpha and beta decay. alpha decay standard equation, we can write a minus 4 z minus 2 plus alpha 4 and 2. Similarly, let's say x a z beta minus decay, this changes into a stays the same, c plus 1. So obviously if you want this same element back, what I mean is x, a doesn't matter. What I mean is if this is c, you want it back, x back, you need back z back, but a plus 2, a dash doesn't matter, this number doesn't matter, mass number. How to do this one? If you add one alpha particle and two beta minus decays, because each beta one put atomic number up by 1, so add two beta minus decays and one alpha decay, it will give you back same atomic number or an isotope of x. So alpha beta minus answer is B. A paradigm shift is something which completely changes our understanding or the way of thinking about a phenomena. Now, classification of variables, scalars and vectors, it has always been the case. From the beginning of mankind, they knew some concepts need only the magnitude, some concepts need magnitude and direction. But if you think about mass and energy, so far we have been thinking mass as a separate concept, conservation of mass, and energy as a separate concept. That's why we have in mechanics conservation of energy. But Einstein came up with the idea mass and energy are interchangeable phenomena. It's the same phenomena in two different forms. So this idea, answer D, the equivalence of mass and energy, was an eye-opener for the scientists. To do question number 24, we need to understand what is the definition of specific energy. Specific energy is energy per unit mass. Now let's think about hydrogen. Hydrogen H2 plus H3 changes into helium. Doesn't matter. If you look at this one, it releases energy. Specific energy is 0.019 U. I am just using the mass conversion without thinking about converting into proper E equals mc squared form. And the mass is, I take it as 5. It is not 5, I know, but I am just using mass number as an indication of the mass. Second situation, uranium 235, specific energy is 0.19 U divided by 235, right? Now they ask to divide these two answers, so I write 0.019 U divided by 5. When I divide, it goes upside down. 235 0.19 U. Be careful, this is 0.019, this is 0.19 only, so I can write, hold on, 23.5 divided by 5, roughly 5. So answer must be C. To do question number 25, we need to find out this equation from data booklet. This one is about the power of a wind turbine. A is the area covered by wind turbine, V is the speed of wind. Now let's think about how to use this one for this question. mgh per 1 second half rho a V3. But there's a problem, because wind turbine is, in this case, is only 50% efficient, so I multiplied by 50% or divided by 2. Now let's write mg, I take as 10, h 12.5, half rho is 1.2, v is 5 to the power of 3, half. But area, I forgot area is 100. If you look at this one, this is 125. 125 is half times 1.2 times 125 times half times 100, right? This 125 cancelled by this one. M equals 120 divided by 4, 30 kilogram. Answer is B. Okay, question number 26. From data booklet, we have to find Wien's displacement law. it shows that wavelength of maximum intensity and the temperature of the body are related by this equation, right? Now let's make a connection. If you take this as the x-axis, this as the y-axis, this is a constant, so this is like x times y is constant. This, what is the shape of this type of graph? Let's use mathematics. By mathematics we know the graph is like this, so answer is A. From data booklet we can find these two equations. This is about interference, topic number 9. First we have to understand that in air refractive index is 1, oil refractive index is 3/2 or 1.5. For water n is 4/3 or 1.3. Now very important thing is to understand is only the middle area, this region has high refractive index compared to both other parts, right? So the phase change happens, let's say a wave comes like this and reflects here only. This phase change is pi in radian. What about the wave which goes inside? No, on this place this is from 1.5 to 1.3 means lower refractive index medium it's trying to move into, so phase change is 0. Actually there's no phase change. Violet will be constructed. Now constructive interference equation for one phase change is this one, so let's use this one. 2d n equals m lambda. M can be 1 or 2 or 3 like that. So d is m lambda over 2 n. So d minimum is when m is minimum, lambda over 2n. This is the idea. Now lambda is lambda is in air. So have they given us the wavelength in the air? Yes, lambda v 2n. What is n? N is the medium. Medium is times 1.5. So lambda v over 3. Answer must be D. Question number 28. The background knowledge we need for this question is, if you have a circular arc, angle is theta in radian, the radius is r, the length of the circular arc is s. These three variables are interconnected by s equals r times theta. Now the question they ask is, they have given you theta and they have given you s, the distance between two stars. They are asking how far the stars are from us. So this is u and these are the two stars. Okay, so actually basically they are asking r, s equals r theta, r equals s over theta. S, the distance between the two stars, is 4 times 10 to the power of 16 meters, and the angle between them is, angle generated is 2 times 10 to the power of minus 7. So this becomes 2 times 10 to the power of 23 meters. That's a very large distance in it. So answer is C. Alright, question number 29 is about Doppler effect. If you check the data booklet, you will see they have given you Doppler effect equations here. This question can be confusing. The reason is the source and the observer are both moving at the same time. So how to simplify this one? Let's think the observer is not in the car. First let's think observer is on the ground. So first situation is source moving closer. So f dash equals real frequency of the wave v minus 40, because source is moving closer. Now let's think, now the observer is in the car. He is in the car and he is moving away. So observer moving away, f double dash. Now the frequency of the wave has already changed because of the source moving, so here I should write f dash times v and v, but observer is moving away, I have to write v minus 20. So now only thing I do is I put this value of f dash into here. So F double dash equals F times V minus 40 times V minus 20 times V. This cancels out. The answer is F V minus 20 V minus 40. Answer is A. This is about a capacitor. To understand this question, let's put some numbers. Let's say this is 0 volt, this is 12 volt. First they say the electric field strength between the plates is this one. This is a uniform electric field. Now uniform electric field strength is potential difference divided by distance between the plates, right? So here, but we know Q equals CV, V equals Q over C. So I can put this one here, Q over CD. So this makes sense. Answer A is right. Electric field lines are at right angles to the plates. That's also true if I make this electric field bigger. Electric field is always from positive to negative and always going out perpendicular to the surface. So this is the electric field. Answer B is also correct. The equipotential surfaces are parallel to the plates. Is it true? Let's say we have 12 volts, right? This is 12 volt, this is 0 volt. How does it change? It changes at regular intervals at regular distance. What I mean is this is 3 volts, 6 volt, 9 volt and 12 volt at same gaps. So the voltage decrease is actually uniform with the distance potential difference. So in this case, answer C is also correct. So the correct answer is D. Question 31. This is about a uniform electric field. Where's the uniform electric field? According to this picture, uniform electric field is here from positive to negative. So what is the force on your uniform electric field? F equals EQ. E stands for electric field strength. But there's another equation. Electric field strength is potential difference divided by distance between the plates, right? So let's add this one. So force equals VQ over D. This is a straightforward question. Answer has to be they asked the charge. So charge equals FD over V. Answer is D. First, to think about orbital periods, I write F equals MA for satellite. G M over R squared M R omega squared. I chose this equation because M R omega is 2 pi over T, so I can think about period in terms of radius of the orbit if I use this equation. Here I will get T squared equals 4 pi squared over Gm. All are constants, but more importantly R to the power of 3. That shows if R increases, period increases. So we have to understand this is X, this is Y. Y has higher period, so Y is greater than X. Answer has to be C or D. Now next step is to think about total energy. Total energy is kinetic energy plus potential energy half M V squared G M over R minus G M over R. This is the potential energy. If you check this one, G M over 2R, this is the total energy of a satellite. But this is very confusing. There's a minus sign, R is below the line. Just think like this. Very simple logic is just like potential energy. Potential energy, you go further. Let's say this is point A and same object goes to point B. Our intuition is height is bigger with point B, so it has more potential energy. Same thing about total energy. R increase, total energy increase. You can think about the radius and minus sign all together, but ultimately the conclusion you will come across is higher the point, you have bigger total energy. So Y is greater than X. Answer is D. Very important to understand that they have given us the magnetic field strength. Now let's think Faraday's law. Electromotive force or voltage is change of magnetic flux divided by time. In 1 second it will go V d distance times magnetic field strength. This I am just saying area times magnetic field strength divided by time, something like this, divide by 1. So voltage generated is B V. This V is different from this one. This means speed, not the same. This means potential difference, times D. Now what I do, I take this one as X, this one as Y, so this must be the M or the gradient. So let's look at the graph. If you look at the graph from here to here, the distance is 6 minus 3. 6 minus 3 is 3. Here 0.5. You don't have to worry about millimeter or any other things. Alright, so gradient is Y value divided by X value is 6. Now I am going to use this one. So B times V is 6, B is 2 times V is 6, V is 3 meters per second. Answer here must be B. Here they say they switch on and off this circuit, and what will happen to this ammeter reading. It's very important to understand when you switch on a DC circuit, what happens is it happens very fast, but actually the current gets into a steady value and then stays constant. We normally don't see this part very quickly happening. Similarly, when you switch off the circuit, same thing, current comes to 0. This also happens very fast. So similarly, the magnetic field by the first coil magnetic flux of the first coil also goes in a similar pattern, because magnetic flux is proportional to the current of the wire, right? Like this. But by Faraday's law, we know it is not about magnetic flux, it is about change of magnetic flux or the gradient concept. So in the second coil, potential difference generated with time is actually like this. Suddenly there is a current for very small time, and then it's like this. But what they ask is before and after. So before and after nothing happens. This is switch on, this is switch off. In between or before and after, current of the ammeter is always 0. So answer here has to be B. Question 35 is about step-up transformer. Step-up transformer looks like this. It has primary coil with few turns, secondary coil with more turns, and this is connected to an AC power supply. The purpose is power equals VI. So our target is to power. You can't change the transmitted power. You have to increase the voltage in order to decrease the current. Why we decrease the current? Power lost in the wires is I squared R. So you have to keep the current lower. So the purpose of a step-up transformer is not anything about current, decrease current. You can say it is step up the current. No, it is not stepping up the current, it is stepping down the current should decrease. So stepping up the voltage, that's right. To decrease the energy losses, that's right. To decrease the power transmitted, no, we want to transmit power. That's the purpose of power lines, right? So it is all about reducing energy losses. This question is about capacitors. Let's think about discharging of a capacitor. The capacitor has some charges, so it is discharging through a resistor. The equation is V equals V naught E minus T over CR. When time equals time constant means CR, V becomes V naught E minus CR over CR. This cancels out, so V naught over E or 0.37 times V naught. It means in this graph, this voltage will become 0.37 V naught in time constant. That is about charging. Similarly, in that's about discharging. In charging capacitor, that's the time for voltage to become, or potential difference to become 0 to 2 V naught over 3 or 0.63 V naught that time. So let's check is the time required for capacitor to charge to the resistor to voltage of, this is right, discharge, no, discharging is V naught to V naught times 0.37. So this answer is wrong. And time constant is product of capacitance and resistors, that's right, answer is B. This is about photoelectric emission. Photoelectric emission, the equation is kinetic energy maximum is HF minus work function. They say work function in this example is HF. So now you send first situation 1. Kinetic energy is K is 2HF minus work function. It does not change, it's always the same. So K is HF. Now situation 2. Now we don't know the kinetic energy is 4HF. They say the frequency is 4 times, right? Minus HF, you get 3HF. But if you look at these three, so these two situations, you can see E equals 3 times K. So answer is C. This is about Bohr model of hydrogen atom. Bohr postulate is, this is given in the data booklet. Let me show you here. This is here you can see this. This means quantization of angular momentum. From here we can write F equals ma. So K E squared over R squared, mv squared over R, and then we can write total energy equation equals kinetic energy plus electric potential energy. By putting these values, this and this postulate, into this one for hydrogen, so total energy equals minus 33.6 over n squared in electron volt. This also a derivation of Bohr model. So these two are correct. This is about Bohr model of hydrogen, but this one is nothing about Bohr model. This is about radioactivity. So it is not related. This is about nucleus. The other two are about the atom. So answer is 1 and 3. Answer is B. Question number 39. Continuous spectrum. If you think about photons from atomic energy levels, what you see is in a dark background you will see different color lines, right? Maybe red lines, blue lines, and different discrete lines. This is called emission spectra of that gas. So this one is not continuous. Gamma and alpha both are individual particles coming out of a nuclear decay reaction, so they always have a certain amount of energy. What I mean is, if you look at gamma radiation from a certain reaction, you will see they can be actually different depending on the energy level of the nucleus, but they can't have any number from 0 to that length. But if you think about beta decay, the nucleus breaks into not two parts, daughter nucleus and the electron if it is beta minus, and anti-electron anti-neutrino, right? This is beta 0 minus 1. This is daughter. This is before and this is after. The issue here is the nature here is these two particles, they share the energy. So the energy of energy of beta 0 minus 1 can be any number. Example, I am just taking an example, 6 electron volt to 0 electron volt, any range. This is called, or if I try to draw number of beta particles and energy, you will see this type of distribution. It means it can be anywhere from these two, between these two numbers. So beta is the one who shows a continuous energy spectrum. Idea is, first thing we have to understand is the density of a nucleus. Mass number or atomic number does not change. Normally 10 to the power of 17 kilogram per cubic meter. So whatever the nucleus, it does not matter, density does not change. So our answer has to be A or C. Now second thing is, there's another equation. Radius of a nucleus is related to mass number. This is called Fermi radius. Okay, first situation, radius is R naught to 1 over 3. Second situation, R dash, R naught, Fermi radius does not depend on anything, times 16, 1 over 3. So first one, second one. So R dash over R is 16 over 2, 1 over 3, 8, 1 over to the power of 1 over 3, 2, 1 over 3 times 3 is 2. So R dash is 2R. So answer has to be answer A.